Back to the CSES dynamic programming series, and today we are going to solve the second question, which is the minimizing coins. So consider a money system consisting of n coins. Each coin has a positive integer value. Your task is to produce a sum of money x using the available coins in such a way that the number of coins is minimal. For example, if the coins are 1, 5, 7, and the desired sum is 11, an optimal solution is 5 plus 5 plus 1, which requires 3 coins. So the input is n and x, the number of coins and the desired sum of money. The second line has n distinct integers, the coins, and we have to print the minimum number of coins. If it is not possible to print the desired sum, we have to print coins. Let's take a look at the constraints. The constraint says that n is less than equal to 100. The sum is 10 to the power 6, and the coin is also in the range 1 to 10 raised to 6. We have the input, we have the output. So let's just okay, yeah. So first, let's just take the input in n x c in n c in x, and we'll create a vector int of coins, which will be of n size 0 for n I equal to 0, I is less than n, I plus plus c in coins of. Okay. So let's try to form the solution, right? So it is similar to the previous question that we have solved, right? And there we could only choose a number between 1 and 6, but here we have a set of coins from which we can form to choose the sum. Also, we have to find the minimum number of ways, and whenever we see all possible ways, minimum, maximum, then we should start thinking about dynamic programming solution. Okay, so first of all, let's decide on the base cases that we need. Like in the previous example, right, we chose dp at 0 to be 1 because there is only one way in which we can form a sum 0 by doing nothing. But in this question, we need to find the minimum number of coins that we need to make sum n. So that's what our dp table will store, right? And to make a sum of 0, how many coins do you need? And the answer is 0 because you won't pick any coin. So the number of coins needed is 0. So that becomes our base case. And let's say what is the, we have coins as 3, 11, 1, 5, 7. To make a sum of 1, what is minimum number of coins I need? I can see there is a 1 present. So obviously we need 1 coin. To make a sum of 2, how many coins I need? So I can pick any of the coins from this. Let's say I pick 1 because it is the first one. So when I pick 1, I pick 1. So my sum reduces to minimum number of coins needed to make 1. But I know that the minimum number of ways to form a sum of 1 will be 1. So the total number of ways will become number of coins needed to perform a sum will become 2. The sum of 2 will become 2 coins. Say sum of 3. So sum of 3, I'll pick 1 and I'll say the minimum number of coins to pick form a sum of 2. Minimum number of coins to form a sum of 2 will be 2. So for 3, I'll need 3 coins. Similarly, for a sum of 4, I need 4 coins. Now let's see sum of 5. Right, if I have a sum of 5, how many coins do I need? So I have two options to pick from these because I can only pick whose s- numbers, the coins, whose denomination is less than the total sum. So let's say I pick 1, and if I pick 1, then first I pick 1, then I have to form a sum of 4, right? So to form a sum of 4, I need 4 coins. So that will be 1 plus 4 coins. So that will give me 5 coins. Or I had an option to directly pick 5, right? So if I had picked 5, so first pick 5, and then I had to make a sum 0, and for 0 I need 0 coins. So I need only 1 coin, right? So that's where we get to know that I have few options. Basically, I can be like, hey, just pick this coin or don't pick this coin, and we'll see later what happens. So if I try to form the recurrence relation, I'll be like, hey, dp at any sum is going to be minimum of dp at sum. Stay where you are. Don't pick anything, right? Don't pick anything. Don't pick this one. Just like we did, don't pick this one. Let's move on to the next one. See if we can do something better than this. Or just pick this one and put a dp of sum minus the picked coin, right? So first option is to not pick. Maybe we can make a better answer by staying where we are, or maybe we can take this one and move ahead, or we can stay there and see we can form better solution. And where does this one come from? This one comes from the coin we have picked, right? We have picked one coin, so our answer should increase by one. Right. Now here comes the catch in this question will be to initialize. Right. Now, if you think about it, it is not possible to form every sum, right? It is not possible. Suppose I, let's say, the changes to 2, and coin here changes to 2, and I need to form a sum of 3. And there is no possible way that I can form a sum of 3 using the coins that I have, right? So the initial answer should be right, or it is impossible possible to form all the sums before we start, right? So that will be our initial answer. So the number of coins needed will be, let's say, coins that we need will be, let's say, very high and int underscore max, right? We need infinite number of coins or invalid number of coins. Okay, invalid number of coins to form this sum. Invalid, which will represent invalid. So if in the end, if the answer is int underscore max, then we'll print this one. So why we can use int underscore max is because of the constraints, right? Int underscore max is approximately 10, 1e9, and we have 10 raised to 6 coins. So the sum will be 10 raised to 6 times of 100. So that becomes 10 raised to 8. So we can obviously use 10 raised to 9. But that will might cause overflow. So we have two options. Either we can use 1e7, 1e8. Let's say use 1e7, which is a very big number. Obviously, we cannot form sum of 1e7. So 10 raised to 6 plus 100 is not 1e7. Okay. So 1e7 will never be. Okay, so let's initialize the vector int dp of x plus 1 comma 1e7, right? And let's initialize the condition, write dp at 0 equal to 0. Uh, Number of coins needed to form sum 0 is 0. For int sum equal to 1, sum is less than equal to x, sum plus plus, right? And for int coin in the array of coins, if sum minus coin is greater than equal to 0, dp at sum equal to dp at sum minimum of stay where we are, don't pick anything, or pick one and go to the solve the remaining part, right? We don't need to do modulus or anything. Yes, we don't need to do. Okay. There we go. And we now need to do if dp at x is 1e7, then it is impossible. So C out -1 such n, or else C out dp at x. Right. So let's check it for the given test case if we can form the sum. Okay, so the answer is 3. It's working. Let's check if we can form a sum of 2, 3. It says -1. Okay. So it's working. Let's try to submit it. It's accepted. Bye.